Hi, today we're going to look at ultrasonic distance sensor. So the basic principle is to have this ultrasonic distance sensor to emit or transmit a short burst of sound, and then it will bounce off this object. Then the echo of the sound is going to get echoed off from this object and receive it back to the sensor. Okay, and then with that we can calculate the distance because we know the speed of sound, right? So let's see how do we potentially calculate it. The speed of sound is 1126 foot per second in ambient pressure or temperature. And if you convert it, trying to convert how many inches for microseconds, you are going to do conversion foot to inch, so times 12, and the second to microsecond is 10 to the power of 6. Then you calculate basically in order to travel 1 inch for sound, it takes only 74 microseconds, right? So imagine if you have this ultrasonic sensor send a signal and bounce off this object and receive it. It takes, this potential duration time, microsecond. And then since it's a round trip, it's going there and come back. So you just divide it by 2, right? And then you times 1 inch per microseconds. Then you can calculate the distance. That's how this ultrasonic distance sensor works. All right, so they measure how long does it take to bounce it back, the time, and then they convert to the distance based on the speed of sound. And this is what does ultrasonic look like. It's a pin sensor, and they have a 3-terminal, ground and 5 volts, and the signal. And the signal here is connected to pin 7 for this particular diagram. It can be anything, right? So how that normally works is the sketch might be different, but the principle is the same. It's like to send, for example, 5 microsecond pulse through pin 7, right? And then they receive it. Then they receive it back, and then they measure time of flight. So this is what we are going to do for ultrasonic sensor. So at the ThinkerCAD, you take out this ultrasonic sensor and let's look at the code. First of all, ground is connected to the ground, 5 volts, and the signal goes to 7. And let's look at the code. And they start with integer, the inches as a variable. They want to measure the distance in inches, and they also measure converted to centimeters. So they measure both inches and the centimeter. And then they read ultrasonic distance. That's one of the syntax. And then here is first they clear the trigger, and then they set the trigger on high stage for 10 microseconds, and then read it. This is when they transmit it, send out the signal, and here they take as an input to read it, the travel time. And they're using the serial monitor here. And inside the loop, they use this formula here using read ultrasonic distance. That's a syntax to read the distance, and then here's a conversion to centimeter. Now that's what we have. Let's go ahead and try what we have here. So we start our simulation. You can start to see it's reading. This object is 44 inches, 113 centimeters away. We can continue to move. You can see when it's further away, it's measured the distance. So that's pretty cool. It's ultrasonic. You see 92 inches, 235 centimeters. It's also showing right here. Then that is the principle of ultrasonic sensor. All right. I'll see you next time. Bye.